Oh, okay, I can't do it. I can't do it. Hello everyone. Happy Tuesday. If I timed everything right, we should have just been, for those of you who are not generous subscribers to the stream, like our friend Nieves here, there should have, I played one 3-minute ad, well, one 3-minute ad section, and that means that for the next hour, we won't have to deal with pre-roll ads. So anyone coming into the stream will be able to and dive right into the content. And it's useful because the stream will only last about an hour anyways. So we wanted to do, so we're kind of trying, hi Faba, she moved a little bit. Wait, if I close the, oh, you know, that worked. She peaced out. Oh, that was perfect. Fava will return. Thank you, Fava. Oh man, I need a clip of that. What was I saying? Yeah, so I wanted to do a practice stream. We're trying this out, this idea to do these. This 1 hour practice streams, trying to do them every weekday that we're not streaming another game or something. We can just practice coding for an hour. Also because I want to practice coding and doing it on stream has certain advantages, certain benefits in terms of consistency and stability and all that good stuff. My timer that I've been using for this has disappeared from my computer, so that's fun. The heck happened to live split? Where's live split? I guess I could use something else as a timer, but like I had it. It was there. Isn't it funny? You know, I was sitting at my desk like an hour ago, being like, okay, I'm early for the stream. Better make sure I have time to get everything prepared, and I prepared a bunch of things, but ain't it always how it is? Ain't it always how it is? The more you prepare, more likely is that this one thing is gonna come knock your socks off. Well, you know what? It's fine. We don't need an external timer. Hello, Ratharius. Welcome to the stream. The stream has started, so we can get these. And we can get rid of the matrix. And we can just let's just dive in. It's not without further ado, right? I'll just look at the time when I start. Why did this lock me out? Oh, back in. So we've been doing. Oh no, this is the lesson I was excited about. I was like, finally, this will hopefully actually explain to me how hash tables work, and that'll be good and useful to me. So let's see what it says. In this lesson, we will explore and gain insights into an essential data structure known as hash tables, sometimes referred to as hash maps in various programming languages. Hash tables play an instrumental role in providing a practical and efficient means of organizing data. Hash tables drive many data storage techniques and in-memory databases, powering large-scale applications such as database indexing, caches, you know, I always used to pronounce that word caches, and even some machine learning algorithms. They store data associatively, linking or mapping values to unique keys. So it's a dictionary, it's just a dictionary. This lesson focuses on understanding the underlying structure and mechanics of hash tables. how they handle conflicts or collisions when multiple keys hash the same index, and how to perform complexity analysis to understand their efficiency. By the end of this lesson, you should understand how hash tables operate and how Python dictionaries leverage the principles of hash tables. Okay, it might be more accurate to say that Python dictionaries are an implementation of hash tables. Making sure to stay hydrated is very important. Understanding hash tables. As we delve into the world of hash tables, let's start by understanding their underlying structure. A hash table consists of an array, the actual table where the data is stored, coupled with a hash function. The hash function plays a crucial role. It takes the keys as input and generates an index, mapping keys to different slots or indices in the table. Each index of the array holds a bucket that ultimately contains the key-value pair. The pairing of keys with values enhances the data retrieval process. The efficiency of retrieving values depends on the hash function's ability to distribute data across the array uniformly. So the idea by using a hash function is, when I'm going to store banana, like if my key is banana and then it can have some data attached to it, the hash function will return a number for banana. It means that whenever I type the word banana, it will return the same number, which can be the index in my array. The tricky thing is you want to make it so that, I can't just use if my array has like 5 slots, I can't just use a very generalized function that's going to give me like the number 100 for the first thing that I put in, because then it goes all the way to 100 and you get it. The point is that instead of me having to remember the number that I'm going to put my data in, I can just remember the word banana. And then instead of having to search through the list to find the key called banana, I can just hash the word banana and then it'll de facto return the spot in the array where the item you want is. That is my understanding of how this works before diving into the lesson. So let's see what they say. You can think of hash tables as hash sets storing tuples of key value, but this particular interface makes it less easy to use. So Python has a concept of dictionaries we will cover below. Let's visualize this with a Python dictionary, which operates on the same principle. Suppose we have a dictionary containing student names as keys and their corresponding scores as values. A simple dictionary illustrating the principle of hashing. Student scores. Tom, 85. Okay, I don't have to read code, right? Student score in student scores.item. So it's a dictionary that holds the key Tom with the value 85, the key Serena with the value 92, the key Alex with the value 78, and the key Nina with the value 88. Also, hi, Gems. I don't remember if I already said hi. And the idea being that when I type in Tom again, it's able to find the bucket labeled Tom and be like, 85. There we go. In this example, Tom, Serena, Alex, and Nina. That's funny. It rhymes. Hi, Nossi. Oh, so fun fact. If you don't pick a color for your username on Twitch, it's kind of random each time. And so on screen, Nossi is yellow today, but on my screen, Nossi is green, and so they have the same color as Jams. I don't know why that's important, but it's a fun fact. Hello, everyone. I hope you're having a great Tuesday. In this example, Tom, Serena, Alex, and Nina are keys, whilst 85, 92, 78, and 88 are their associated values. Under the hood, the Python interpreter uses a hash function to assign each key value pair to a unique address in memory. Yeah, you can, I forget. See, I have so many add-ons installed on Twitch that I can't even open the chat settings normally to change my username. Because like 7 Twitch TV and Better Twitch TV and Franker Face C are all arguing about who should open the settings dialog in the dashboard. It's good to be many colors. I guess that's why gays love rainbows. Why plural systems love this symbol. This is a version of the emote that we made ourselves, by the way. We used vector graphics. I'm really pleased with how it came out. I'm never sure about the colors I picked, but they're nice. They're good colors. What was I talking about? Who was I? Who am I? I'm Minu. It says on screen that I should be Minu, so I should act like Minu. Collision handling in hash tables. There are instances when two different keys produce the same index after being processed through the hash function. The situation is known as a collision. When a collision occurs, we are faced with a dilemma. Where do we store the new key value pair since that index is already occupied? Here are two common strategies to handle such a scenario. Chaining. In this method, each index or bucket in the array hosts a linked list of all key value pairs that hash to the same index. When a collision occurs, we simply go to the collided index and append the new key value pair to the existing linked list. Open addressing. Upon encountering a collision, the hash table searches for another free slot or index in the table, possibly the next available empty slot, and assigns that location to the new key value pair. This approach requires a suitable proving strategy to ensure efficient use of table space. See, John Smith and Sandra D. So the interesting thing about these two methods, chaining seems well enough and good. Open addressing, it's also probably okay, but this is something interesting. This is something that people who have been programming in Python their whole life might not realize it. But in Python, you can just like give a list and then append however many values. You can just like keep appending to the list, right? Wow, I'm so glad that when I opened this this document, there was already a list there with an append method. And Python just does everything for you. But back in the day, back when we started learning to code, back in the day, when we were doing C++, in C++, you had two different concepts. You had arrays, which you had to declare, and you had to say how big you wanted them to be. You would be like, I'm going to need a chunk of 5 memory addresses, and I'm going to put stuff in it. And if you wanted to put more stuff in it, you had to be like, okay, well, we have to double the size of the array. Which leads into another common thing to use in C++ were vectors. A vector behaves much more like a Python list in that it is dynamically sized. It changes sizes as you add things to it. I wouldn't be surprised if Python on the back end just used something similar to the vector, because the thing about vectors, as I remember them, is that, you know, it started maybe as an array of 2. You put 2 stuff in it, and it's like, okay. When you go to put in the third one, it's like, okay, let's make it 4 now. And then when you go to put in the 5th one, it's like, okay, let's make it 8, and so forth. And it always doubles in size. maybe that's just like a one very specific implementation of it, but I suspect Python does something similar in the backend when you do lists and when you do dictionaries. And this is my prediction. I wonder if it'll be explained to us, otherwise we can look it up. But I suspect that when Python does dictionaries, I don't know. Maybe I don't predict this, but I'm saying a third way to handle a collision would be if you're using a hash function that corresponds to the size of your set, meaning you have a 5 function that for 5 different inputs will give you only 5 different numbers. You would probably want to change your hash function. You could probably pick a hash function that will, for the first 5 values, still give the same index, but then for the new values would give a different index. And I wonder how easy it is to like custom pick a hash function like that. Otherwise, you would want to remake your hash table again using the new hashing function, using the old table to populate the new one. When these operations are abstracted away from the user, you might not notice them, except that if you do like a deep in-depth analysis of your program, you might see it pop up as like places where your program starts to chug because it has to do a lot of memory operations in the background. There's probably where people like Rust. I'm just, a software engineer. I'm like a journey person, software engineer. I know how to do shit with the tools. I'm still learning to understand the deep mysteries. So people who know the deep mysteries prefer certain types of programming languages because they might do things more elegantly or more safely in the background. And then there are people who say, okay, but like it's bad. It's bad to do things in the background. Back in the days of C, you had to like gambare, James, gambare. You have to back in the days of C, you had to do it all manually. You had to like mine all of your memories. And if you tried to add to a table that was already full, it would like, oh, I'm getting pets. It would get fucked up. And so personally, I prefer it to have my programming language do things for me, but I do understand that it's important, especially as you progress in the field. If you want to achieve mastery, you have to start to understand these deep mysteries. And so that's what we're trying to do here today together. And thank you so much for being with us on this journey. Moving on. The image below provides a visual example of chaining collision resolving method. John Smith and Sandra D. Look at me, I'm Sandra D. Blessed with virginity. Won't go to bed till I'm legally wed. I can't, I'm Sandra D. Have the same hash function result. So their entries are organized in a linked list in the corresponding bucket. Yeah, so if you type in John Smith, you get 152, and then I don't quite understand. If you type in Sandra D, how does it know? Like, it's including what's happening here, right? Okay, you go here and you see that you have two options. You can either take John Smith. I guess you can do an if. You can, at that point, you can just do an if. If the key that you asked for was John Smith, this number. If it was Sandra D, this number. Who are these people? John Smith, Liz Smith, they must be married. Sam Doe, John's cousin. Sandra D from Greece. And Ted Baker. Time and space complexity analysis for hash tables. Hash tables are renowned for their efficiency and speed when it comes to data storage and retrieval. They boast constant time complexity. Oh no. Oh, my thinking is being stored for prosperity. They boast constant time complexity O of 1 for the operations and key value pairs insertion, deletion, and retrieval. This efficiency comes from a good hash function, which allows for keys to be uniformly distributed across the table and accessed directly via their indices, eliminating the need to scan through unnecessary slots. Although hash tables generally perform robustly, situations may arise where frequent collisions occur. Such situations could deteriorate the table's efficiency and extend the time complexity to a worst-case scenario of O of n, where n is the number of keys hashing to the same index. So again, because with the John D and Sandra D example, normally it's if I plop in Ted Baker, it's just a matter of running the hash function, you get 153, and then immediately you can go, okay, this is the value the user wants. But you can think of that as one step, whereas if you do Sandra D, it has to do that same step, but then it has to go one step further to go down. John Smith could potentially be about as quick, except the check for when you have to check, was it John Smith after all, or was it Sandra D? That might add a little more time, because if you're just doing like string comparison, that might take longer. And that's when it went from being 1 to 2, and it's like, if for whatever reason, if all 5 names ended up in the same value, then you would have to do 5 times each time. This also means that if you do a chain listing or you do like an open addressing, if you don't change your hash function, you make it so that that value is now forever more expensive than all the other values, right? And that, maybe you can handle it if it's just one value, but as more and more collisions happen, it becomes worse. Working with hash tables in Python, dictionaries. Python provides a built-in implementation of hash tables known as dictionaries. Dictionaries in Python work similarly to hash tables. They allow the use of arbitrary keys to access values and handle collisions seamlessly behind the scenes, ensuring consistent and quick access to stored data. You can create a dictionary with key-value pairs, access values using keys, and perform various operations such as adding new key-value pairs and deleting them, as demonstrated below. Okay, sometimes, the thing about reading aloud, sometimes I will read a paragraph and then be like, okay, now I actually need to read it, because I was literally just taking in words and putting out noises. What the hell did it just say? Dictionaries. Sure. This is already what I like basically said, where the key is kind of like your hashing key. I suspect that it is not as simple as Python just hashing whatever your key is, right? Especially because Python allows you to have it doesn't allow you to use quite anything as a key, but it's not as fun, is it, right? Like I could have like Favor read it to you or anything, but like you pay good money to see and listen to the fairies. Why would I just sit here and let an AI replace me? I think this website will do it also, and I told it to do it once and I didn't like how it sounded. But I will reserve that as an option for days where I might not feel like reading aloud. But I do think it will be cute to do something like have Faybot do it once we have like a consistent voice for Fair. Um, who knows? Maybe we can have characters. We can have characters read different things for us. Um, we can collaborate with Faybot on reading stuff aloud. Um, but yeah, all it's saying is Python dictionaries from the outside would seem to operate very similar to hash tables in that you just give them a key. So key Moby Dick, value 8, key the Great Gatsby, value whatever. Oh, the Catcher in the Rye. And the thing that we haven't mentioned explicitly, but that you might have gathered, is that keys have to be unique, but values don't, right? So Moby Dick and The Catcher in the Rye both get 8s. Are these out of 10 or out of 100? I've admittedly only read The Catcher in the Rye, and personally, I kind of liked it, but I don't know if it's an 8 out of 10. And then War and Peace is a 10 out of 10. Supposedly. Oh, this is the. I didn't have the. Oh, my name is up there now. It's gonna cause problems later, but it's okay. Access a value if it's key. This happens in one time, so you can just be like Moby Dick and you get 8. You can also use the full value if the key is not there. I do want to read Moby Dick. It's on my list. I keep thinking about this because I have a couple of books that I want to read that are more literary fiction, but I don't completely understand what the term means, but it's, I've been reading a lot of spec fic and I'm like, oh, I really should try to, or I do want to read things that are not spec fic, but just haven't gotten around to it, I would actually say I want to read all the books in this list, just because, they're considered classics. The Great Gatsby, it's this book that every single US person I've met has like a weird relationship with because it's like assigned reading in American schools, but I didn't go to an American school. Maybe it's similar to how I feel about 100 Years of Solitude, except 100 Years of Solitude, it's I think the public perception of 100 Years of Solitude is more popular than Gatsby. Okay, that's good to know. That's a sounding recommendation. I'll read it. I'll definitely get around to it. And apparently, I understand it's not very long either. Where is such a tension here? What happened to dictionaries? So the difference between just using this is that this will fail if you provide a wrong key, but using get you can output like a default value. To Kill a Mockingbird. Okay, I can't remember. Did I read it? I've definitely seen multiple adaptations of it. I saw the movie. I saw a play that was incredible. I cried. I can't remember if I read the book as a book. I think I did. Um, Again, is it a 9 though? Like, it's very, very important in context, but in terms of like as a book, is it a 9 though? Is it? I'll let you be the judge of that. You can update values. They downrank Gatsby. They're like, well, if to kill a mockingbird is 9, Gatsby must be an 8. Print book ratings. And you can delete, and that's also because you just hash War and Peace. But like, and if dictionaries, I don't know how dictionaries work. I haven't been told how dictionaries work. If I'm not told, I might have to go look it up. But well, no, because I'm like, a good hashing function would allow you to put something else eventually in the slot the War and Peace occupied it. Something that's not just War and Peace again. Otherwise, like, that slot's gonna be empty forever until the time that War and Peace comes back again. Summary and validation of lesson goals. Necessary. Today's lesson has taken us on an exciting exploration of hash tables and their equivalents to dictionaries in Python. We've uncovered the intricacies of hash tables, how they manage data, prevent collisions, and their time complexity under different circumstances. Understanding these concepts is key to leveraging hash tables in different application scenarios, software engineering, and data analysis. Now you are well equipped with the knowledge of what a hash table is and how to use it in real-world applications. Practice exercises are coming. Now that you've journeyed through the theory behind hash tables, it's time to solidify this knowledge through hands-on practice. In the next section, we will tackle various practice exercises based on what we've learned so far. This will pave the way towards a deeper understanding of hash tables, their implementation in Python, how they can be employed to solve different problems. Keep learning and keep growing. Fuck off, Cosmo. I hate you. I fucking hate you. Maybe I should do this. Start doing this every day, except I don't remember how I did this earlier. But this won't take this will just pay no attention to the break core. What the fuck? You're trying to add extensions. Will this work? Perfect. Did it actually work? Well, fuck it. We'll deal with that later. Are you ready to dive into some hashing practice with Python Dictionary Space Voyager? Let's imagine you're responsible for cataloging books in a spaceship library. Oh look, let's try this out.
Are you ready to dive into some hashing practice with Python dictionaries, Space Voyager? Let's imagine you're responsible for cataloging books in a spaceship library.
Okay, I just want to say I do a much better Cosmo voice than this model. Just saying. Just saying.
Each book has a unique ID which corresponds to a specific title. Your task is to run the code and observe how a dictionary processes these book IDs and titles. It will be akin to implementing a hash table. The code will demonstrate how addition, access, and deletion operations function within a dictionary, showing the key functionalities of a hash table. Press the Run button to watch Python dictionaries in action.
So this is just a demonstration. Let's create a simple hash table in Python using dictionaries. We'll store information about books in a library where each book has a unique ID and a corresponding title. The ID is the key and the title is the value. So this is like storing books based by their ISBN or whatever instead of anything else. But then it's like, okay, the first book, Catcher in the Rye, second book, To Kill a Mockingbird, third book, 1984. Print initial book library for key value in book library items. So this will just print everything, and it uses an F string. Oh, first appearance of the F string. And now let's attempt to add a new book with an ID that's already used. And then, so this will just overwrite the Catcher in the Rye. Now let's remove the book with ID 2. And then it just tells you, by the way, that was all sub 1. So yeah, we replace Catcher with Moby Dick, and then we just deleted thing, and then we still have 2. This still hasn't told us where hash functions come in. Congratulations on completing your first run, Space Voyager. Now it's time for a deeper dive. Assume you are managing events within an event system. Could you modify the starter code to update the description of the Python webinar and verify the final events list? We need to clarify the Python webinar is going to be focused on data structures, and we should also reschedule it to a different time. I thought you were going to teach me how to do hash tables, and you're just teaching me how to do dictionaries. I already know how to do dictionaries. What am I? Alright. Update the Python webinar description. Don't change previous definition of event system elements. Print the updated events list. So we need to clarify that the Python webinar is focused on data structures. Wait. Okay. No, don't change the previous definitions of event system element, but it should be event system to Put it at 1 p.m. Maybe make more sense to do like an algorithms book or something. Why don't you take this one, Cosmo, whilst I drink some water?
Fantastic progress, future space engineer. Now, let's take an even bigger leap with Python dictionaries. The starter code provided manages space mail received from different space stations. Each station sends a unique ID along with their messages. Our system records all incoming messages, removing them once we've read them. However, we've received a message from an unknown space station not recognized by our current system. Should you choose to accept it, your mission is to add this incoming message using a unique ID and verify that all received messages, including the new one, are updated in our system. Venture forth, Stellar Navigator.
It's interesting that the new station has the same okay. Removing them once we've read them. Doesn't say. Oh, well, let me just do space mail station delta equals Vods colony report. After 10,000 years, we've reestablished communication. Please send a maybe it's only been 100 years. That was it. That's all they wanted. They didn't even want me to delete the messages or anything. Well done, Space Voyager. We're on the home stretch. This is the last practice exercise for hash tables. You've aced all the tasks thus far. But can you handle this one on your own? In our HR system, we maintain an employee database. Each employee is assigned a unique ID, and their role is tracked against this ID in a Python dictionary, which constitutes our hash table. Your task is to create an initial database with various roles and simulate a scenario involving a promotion and an employee departure while updating the database accordingly. Remember, this requires the addition, retrieval, and deletion operations that we've learned about in addition to the time complexity analysis for these scenarios. Good luck. Okay. to employee database. Create a Python dictionary. Add employee names with the roles to the company. Hello. Employee database. Okay, here we go. Nieves, what's your role in the space, in our space company? Or, you know, and so everyone who's in chat, this is your chance to submit your preferred role for space. If you do it before I do it for you, I'll just assign a job for you. I'm the captain. James is our security officer. I guess if you do provide me with a different job, I can just use that as your promotion. Nosy is our Starship Mystic, and I mean Nieves is bartender. In the initial employee database. For comma 4 name comma job in. We should take a note of this. You can't scroll up, can I? Save this for me, please. No, please don't. Please don't. Please go back. This is not what I meant to do. Alright. For an employee in employee database. Wait, why does this mess up sometimes? Print. Does print line still work in Python? No. I really wish I could see some of the code from previous steps without having to reopen everything. I wish I copied and pasted things. What happens if I okay. Doesn't have what to though. For event ID in event systems with items. That's what I was looking for. And I also need. All right. Print already does a new line for you. For some reason, maybe all this talk of C++. In C++, there's like print and print line, and for one you'd have to like add a new line character. It would just print, etc. Printf Starship Crew. I like how this is just... It's just VS Code reskin. Let's see how well this works. Starship crew, Transferry, Starship Captain, Jam Security Officers, Noshi, Starship Mystic, Nieves, Bartender. Update the role of an employee database. So... Maddie, you're getting promoted. You are now quartermaster. Remove an employee from the database. Me. I'm leaving. You all are all on your own. Good luck without a captain. You did it. Excellent job, Aisling Faye. Let's keep going. Nice. Sure. Alright. We did it. We finished a whole lesson with a little bit of time to spare. So yeah, so I don't know. Part of me, so like every time we do this, I complain about the complexity and the in-depthness of the course, and it makes me wonder, like, should I finish it? Should I do something else, etc., etc.? Should I try a different website? I don't know. I guess, like, the worst comes to worst, like, it is practice. It's just I don't exactly feel. I feel like I'm solidifying certain things, which is useful, and I did learn a couple things. I have learned a couple things so far. So I'm tempted to keep giving it a chance. It is good that it's like nicely structured for me, even down to the fact that each lesson seems to take about an hour, so I can do like a lesson a stream. So like we finished 4 lessons in about 4 streams. It's like I could do worse, though I was kind of imagining that coding practice would look more like, oh shit, I need to implement a depth first search algorithm. Oh shit, I need to implement a regular expression checker. Or oh shit, like things that I actually feel more like I need to practice. We'll keep thinking about it. I think the most important thing is going to be consistency, right? For me to try to do it on a regular basis on a schedule. I also do enjoy the fact that it's kind of easy stream content. You know, I sit down, I read some paragraphs of code, I do some exercises. Bing boom bang, it's a stream. And people seem to be enjoying them so far, so that's nice too. tomorrow it's Tuesday, and we'll probably do like we did last Tuesday. We'll do this for a little bit, and then maybe we'll work. And that's the thing. I haven't decided, or we haven't decided. I haven't even decided if I'm gonna do the stream or if Ember's gonna do the stream. I've been kind of doing a lot of streams lately, and yes, a third surprise system made. Who knows? And I don't know, are we gonna work on Fable Twitch or Fable Discord or New Brownie Bot? We're kind of leaning towards New Brownie Bot because we left it unfinished. But I'm also like, oh man, we're going somewhere with Fable Twitch, and we've kind of like stopped working on her. I don't know. I guess we'll see what we feel like tomorrow. Maybe I'll ask Claude. Maybe Claude will help me decide. Of course, if there's anything, and if you all want to see specifically, as long as it's like a software game development related, so it could even be like doing Unity stuff. If there's something that you want to see more of, please let me know. Because I want you all to feel like this stream is for all of us. It's primarily for us, the fairies, but the stream is nothing without its viewers. So we appreciate you all so much. Thank you so much for watching. We're gonna wrap up. We're probably gonna rate someone. If you enjoyed the stream so far, remember to hit it with a like. Remember to hit it with a follow. Remember, you can subscribe to the stream to get ad-free viewing, and also, if you have Amazon Prime, you get a free subscription. So you can, for free. Yeah, see, Jams knows how to do it. You can like the stream by just liking the stream. You can follow the stream by clicking the little heart icon, and you can support the stream by telling your friends about it, or by being a good person. You can support the stream by being excellent to each other. That's what I'm trying to say. Who can I rate? Oh, Tina Hacks. Tina Hacks is playing Final Fantasy. Georgia's playing Zelda. It's not quite, none of it is quite coding, but none of my friends are coding. We could pick a new code streamer. Or something. Yes. The petting emotes are a nice perk of subscribing. You know what? No rate today. You all have a great rest of your Monday. We will see you tomorrow for more streams. Take care.